about case study on complex number. First, Gautam, say what is complex number?
Complex numbers are numbers that have both real part and imaginary part. And they are written in the form of a plus ba, where a is the real part in the equation and b is the imaginary part. The symbol I represents the imaginary unit, where I is equal to root under minus 1. This means for if we are doing an equation to solve the problem, I square we can take in the form of minus 1, which will help in our which will help us to work with square roots of negative numbers now. And complex numbers were introduced to solve equations that does not have real solutions. For example, we can take in the if my root under minus 9 is there, we could not solve the solution. With the help of complex numbers, we could write it as 3i. So that represents root under minus 9. And a complex number can also be represented in the Argand plane, where horizontal plane represents the real numbers and the vertical plane represents the imaginary numbers. The Argand plane is a graph used to plot and visualize complex numbers. And it helps us visualize addition, subtraction and magnitude of complex numbers. And here as of I said that real part is the horizontal axis and the vertical part is the imaginary part. And the complex number a plus ba is plotted as a comma b. This representation also helps us to visualize complex number as points or vectors or in a plane. And because of this property, complex numbers are very useful in engineering mathematics and engineering physics also.
Complex numbers were first introduced when solving cubic equations. Cardano discovered them in the 16th century. Later, Raphael Bombari explained how they work mathematically. At first, mathematicians thought they were useless and imaginary. Today they are essential in physics, mathematics and engineering. Operations on basic complex numbers. Complex numbers follows normal algebraic equations like the basic operations are addition, subtraction and multiplication. Addition, while adding the complex numbers, the real part and imaginary part are added together. For example, a plus bi plus c plus di is equal to a plus c plus b plus di. Subtraction, while subtracting the complex numbers, the real part and the imaginary part are subtracted separately. For example, a plus bi minus c plus di is equal to a minus c plus b minus d of I. And multiplication, a plus bi into c plus di. Remember, I square is equal to minus 1. These operations are helps to solve complex equations.
Does anybody know analytic function in complex number?
Analytic function in complex number goes like it will be it will be given as a complex number. That number is differentiable at a point called z0, and it is differentiable at that point as well as the neighboring values, like it might be z1, z2, like that. That is known as analytical equation.
If it is analytic function, it satisfies?
It satisfies Cauchy-Riemann theorem, which is equal to Vx is equal to Uy and Vy is equal to minus Ux.
So also define the harmonic function.
Harmonic function will be like it is the double differentiation of the given complex number, which is u double x plus u double y, differentiating both double differentiating both with two different variables. If we add them both, we get 0. That is harmonic.
Variable x and y also. So we have two second order variable, that is
for two different variables.
Ux plus Uyy equal to 0. So we take right hand side, then we have to find the left hand side, that value is 0, it is a harmonic.
Going to the applications of the complex number which we have discussed here. The application of complex number is not just only in mathematics. It can be around physics, any other subjects in our daily life. Let us going through the analytical department. In the analytical department, in our laboratory, we usually used a function generator, which could go through a graph points, where each and every point in the graph have some complex number value, which we can get determined by the formulas which we are using there. Next, coming to the signal processing. each and every signal which has been sending and transmitting and receiving through an electrical component is just only because of the digital signals, which can be also complex numbers which comes under the coding. In quantum physics, which is nothing but the electrons, neutrons, and protons, the separation value, the energy density, its presence in the everywhere in the space, everything comes under a complex number as in a graph. So in our daily environment, we are coming through the complex numbers which are there in the environment. And another interesting thing is that some of them are well being in the games, video editing, which is possible only because of the complex number which are behind the process.
So this we have to learn is that complex number which includes real number as well as imaginary number is a very integral part in learning various topics like mathematics, quantum physics, electricals, etc. In mathematics, it's generally used for the Argand plane geometrical form and vectors to find the moment vectors, position vectors, etc., which is very essential in the developing which is very essential in recent developments of, like he said, games, and as well as detecting the motion of a human while tracking someone. If we are tracking someone, like where he is, and Google Maps requires this many stuff. Then in quantum physics, it's used in different various to understand the movements of electrons and protons under the very nanoparticle size, which is nowadays a very interesting as well as a threatening concept to see what is inside. Humans are reaching where it's not even necessary to reach, so that is a different thing. Then we can learn in electrical, it's for the waveforms, sine waveforms. We have learned many things which represents in graph, in which there are imaginary values where the graph vanishes, like infinity is the imaginary value. Thank you.